Hi everyone. Today we're going to be talking about within the concept of asymptotic notation and analysis. This concept that we often use the equals notation as a replacement for inset notation. Just make sure we cover all the concepts about it, okay? So this is all about the concept of asymptotic analysis and notation. We have covered the overall material in one of the videos. I'll link it in the description below. Today though, we're going to be just talking about this concept of set versus an item in the set. As alluded in the original video as well, normally we have a set S, and within that we can have an item X. So we write it as X is contained in the set S. Now the set S can also be a set of functions, and a function F can be in the set S. We would simply write it as F is contained in set S. However, sometimes for shorthand, we might write as F is equal to S. This is just done informally, as long as the context is clear that we mean to say that the function F is in the set S. The example we have in our context is in asymptotic notation. We say that F of n is equal to big O of G of n, but strictly speaking, big O of G of n is a set of functions. The set of functions that grows no faster than G of n. So what we are simply intending to say is that function f of n grows no faster than g of n, and therefore it is simply in the set big O of g of n. And most computer scientists are comfortable with the notation saying that f of n is equal to big O of g of n. Okay, so really that's that. Feel free to use the in equals notation as long as you know what it means. Now, if you tell me in a homework or a project or something that f of n is equal to big O of g of n, I will just assume that you mean that f of n is in the set big O of g of n. In most cases, it'll be just fine. In some cases, this can be a little bit confusing. For example, if we say Cn is equal to big O of n, most people would agree with it. If we were to write Cn is equal to big O of n square, many people might object to it, saying, hey, that's not right. However, it is mathematically correct. That is because we are saying that Cn is in the set big O of n square, and that statement's true. Cn is indeed in a set of functions that grows no faster than n square. Now, the more accurate statement here is that Cn is in the set of big O of n, but maybe if the function is hard to analyze, maybe we don't know what the better accurate statement is. So the first time complexity of the function that we analyze it to be, maybe that may prove to be a loose bound. Like in this case, to say Cn is equal to is in the set big O of n square is a loose bound, even though it is mathematically correct. And the reason for this confusion can sometimes be because when we use the symbol equals, subconsciously, we think of that as an equivalence relation. In mathematics, an equivalence relation is a binary relation that is reflexive, symmetric, and transitive. So we assume it's transitive. So when we say function f is equal to set S, then we might say function f is equal to another set S. So we think, oh, then set S1 and S2 are the same. But of course, they don't have to be the same. An item may be in two sets which are themselves not the same. So Cn in this case is in the set big O of n, and it's in the set big O of n square, and they're not both the same sets. They are different sets. So again, as long as you understand the concept, feel free to use it. You understand these occasional pitfalls, you're fine. If you say that f of n is equal to big O of g of n, I will just assume that that's what you're saying, is that f of n is in the set of big O of g of n. In most cases, it will be just fine. So that's all I have to say about that. Keep learning, enjoying, okay?